Okay, today we're going to talk about parabolas, and many people may not actually know what the definition of a parabola is. And so let's just actually figure out what a parabola is. We know that it makes the U shape, and we've been doing parabolas and graphing parabolas and studying parabolas since 8th grade math. But what exactly is a parabola? A parabola is the set of all points in a plane that are equidistant or same distance from a particular line, and that line is called the directrix, and a particular point in the plane, and that point is called the focus. So that probably still doesn't make any sense, so let's see if we can draw it out. So let's say we have a parabola and it has a center HK. So maybe we'll put that right there and we'll draw our parabola. All right, so we've drawn our parabola, and some distance, let's just say some distance from the center, we'll call that distance P, is some special point called the focus. And we'll talk about that in a second. And some other distance P away from the center or in the opposite direction of the center is called a special line called the directrix. And so we'll draw that line right there. It's not always on the x-axis, but in this case I'll just draw it right there. And so this is also a distance of P. And so basically a parabola is nothing more than the set of all points where every point on the parabola has an equal distance from that point to some line called the directrix, and that same distance to the focus, which is another special point. And so maybe there's another point over here, and maybe we'll put that in dark blue. And so maybe there's some point right here, and that point on this parabola is the same distance from the point to this special point called the focus, and it's the same distance to this line called the directrix. And even though I didn't draw it to scale, basically every single point on this parabola is going to have that same property, that the distance from that point on the parabola to some special point called the focus is going to be the same distance from that same point on the parabola to some other line, and we're going to call that line the directrix. So let's just write that out. The directrix. All right, and so the directrix is going to be some horizontal line, y equals, and we'll just say k minus p, because the center of the vertex of the parabola is hk. And so do you notice that the directrix is located a distance of p below or above if it's an upside down parabola. In this case it's a right side up parabola, so it's going to be a distance of p below the vertex, and so therefore this line is going to have the equation y equals k, the y coordinate of the vertex, minus p. And of course the focus is going to have coordinates of h, we'll put this in light blue to match the focus, h, comma, k plus p, right? Because it is the same x coordinate as the vertex, but the y coordinate of the focus is the y coordinate of the vertex, k, plus a distance of p away from the vertex, so k plus p. And the axis of symmetry is the line that goes right down the middle of the parabola. And so that line goes right through the vertex, and it'll be a vertical line, so that's going to be x equals h. And we have that right there. And now we have something called the focal length. We've talked about that. That is the letter P. It is once again the distance from the vertex to the focus, or the vertex to the directrix. And then the last thing we want to look at on this table is called the focal width. And that's just 4 times P. And that is simply the distance from one point on the parabola through the focus to the other side of the parabola, and that is 4 times p, and that is the focal width. So now that we know all these different letters and what they mean, let's just see if we can work it out on some problems. Okay, so in this first example, it gives us the parabola y equals -1/2 x squared, and it wants us to find the focus, the directrix, and the focal width of the parabola. So the first thing you want to do in these problems is you want to identify what type of parabola is it. Is it a parabola that opens up and down, or is it a parabola that opens right and left? And it's pretty simple to identify this. If it's y equals x squared, then that's just the parabola that you've always been used to drawing. That's an up and down parabola. If it's in the form of x equals y squared, then that's going to be a right and left parabola. So in this case, we have y equals x squared. That's an up and down parabola, so we need to focus in on this column right here. We'll say all of these equations right here. So first thing we want to do is we want to rewrite this so that the 4p is in front of the x. So we probably should have written it like this: 1 over 4p times x minus h squared equals y minus k. Now in this case, you notice that we do not have y minus anything and we do not have x minus anything. And so therefore we can see that the vertex of this parabola is going to simply be 0, 0. And we know this is going to be an upside down parabola because the number in front of x squared is negative. So we can already just draw an upside down parabola. Now the question is, where is the special point called the focus? And so let's see if we can find that. Well, we have 1 over 4p, and notice that the 1 over 4p is the coefficient in front of the x, and in our problem, -1/2 is the coefficient in front of the x. So what we'll do is we will set 1 over 4p equal to -1/2. We will cross multiply. We'll get -4p is equal to 2. And then p is equal to -1/2. And so once again, let's remind ourselves that p is the focal length. It is the distance from the vertex, and the vertex is 0, 0 in this case. And so the focus is just some distance from the, actually this is the directrix we're going to draw right now, and that is some distance p from the vertex. The focus is some distance of p inside the parabola. So make sure we understand that. The focus is some point inside the parabola. The directrix is some point outside the parabola. So the directrix is simply going to be the horizontal line that goes through that point. So that's going to be y equals 1/2, because p is -1/2, so it's going to be a half up from the vertex. And then the focus is simply going to be 0, -1/2. And so that's going to be your focus. And so we've got the focus, we've got the directrix, and now it wants to know the focal width. So once again, let's remind ourselves what the focal width is. It is the distance from one point on the parabola through the focus to the other side of the parabola. And our formula says that is 4 times p, the absolute value of 4 times p. And so p is -1/2, so it will be 4 times -1/2. And so that's going to be -2, so the absolute value of -2 is 2. So this distance from here to here is 2, and that is the focal width. This p is the focal length, that's 1/2. The focus is 0, -1/2, a point inside the parabola, and then the directrix is going to be y equals 1/2. Okay, this next problem is pretty easy. It says find the standard form of the equation for the parabola with a vertex of 3, 4 and a focus of 5, 4. Notice the hint. It says always sketch the vertex and the focus so that you can see whether the parabola is a horizontal or a vertical parabola. And so let's just go ahead and do that. Let's say we have 1, 2, 3, 4, 5, and 1, 2, 3, 4. And so we know that the vertex is over 3 up 4. And so we'll put a point right there. And then we know that the focus is at 5, 4, so over 5 and up 4. Now what does that tell us? We know that the focus is some point inside of the parabola. So that must mean that the parabola opens up this way, with the focus being inside of the parabola. Now, if this is the point 3, 4, just put that right here, 3, 4, and this is the point 5, 4, then what is the distance from the vertex to the focus? Well, that's a pretty simple question. That's a pretty simple question, pretty simple answer. P is 2. That is the distance from the vertex to the focus. And that is what the letter P stands for. So we now can write our parabola. So we know that this is a parabola opening to the right. So that means we need to use this equation right here. So it's going to be y minus the y coordinate of the center, which is 4, excuse me, not the center, the vertex, excuse me, squared equals 4 times p. P we've already established as 2. And then x minus h. H is the x coordinate of the vertex. That's 3. So your final answer here would be y minus 4 squared equals 8 times x minus 3. Okay, example 3 says use your graphing calculator to graph the parabola y minus 4 squared equals 8 times x minus 3. And your first instinct may be to think, well, what in the world is this problem asking me to do? But you have to remember that before you can graph something on your calculator, it has to be solved for y. It has to be y equals, and you can't be x equals because the calculator doesn't have that feature. So I say most calculators don't have the feature to graph x equals equations, only y equals. So that means we need to solve this equation for y. So to start, well, we'll just rewrite it first. And we'll start by taking the square root of both sides. And so that's going to get rid of the squaring function. So squaring and square root are inverses of each other. They're going to cancel out. And then a mistake that a lot of students make right here is they forget to put a plus or minus in front of the square root. So that's going to be plus or minus 8 times x minus 3. And then we're going to add 4 to both sides. And so we get y is equal to 4 plus or minus the square root of 8 times x minus 3. So what is this graph going to look like? Well, it's going to look like an upper square root curve. That's what you get when you have 4 plus square root of 8 x minus 3. And then if you were to graph 4 minus the square root of 8, you would get a lower square root curve. And when you put an upper square root curve with a lower square root curve, then that's going to create a parabola that opens to the right, which is the same as what we have here because this is an x equals y squared parabola. Okay, this next example says prove that the graph of y squared minus 6x plus 2y plus 13 equals 0 is a parabola, and then find its vertex, its focus, and its directrix. And so first thing we want to do here is we want to complete the square. And so we have here y squared. So what we'll do is we'll group the y's together. So y squared plus 2y plus we'll leave a blank. And we'll move all the terms with the x to the other side. So we'll add 6x to both sides. And we'll subtract 13, put it over there. And now we're going to complete the square. Let's review that. You're going to take half of this middle term. Half of 2 is 1. Square that. Do not forget to square that. So that is going to be 1 right here. And you can't add 1 here without adding 1 to the other side. So you're balancing your equation out. Why do we do this? Because now we can factor this into y plus 1 and y plus 1. However, we can write that as y plus 1 squared because it's always going to be half of this middle term. That's going to be the shortcut. So it's going to be y plus 1 squared equals 6x minus 12. Now we can factor out a 6, so we get y plus 1 squared equals 6, and then x minus 2. And so now we can see what type of parabola it is. This is going to be an x equals y squared parabola. So it's going to be opening up to the right. And so we can now find the vertex. And if we notice that the vertex is HK, so let's circle that. H is the number after x minus. So the vertex, let's just write that here. Vertex is going to be 2, comma, negative 1. It's counterintuitive. And so we have the vertex. And the focus we will get from focusing, no pun intended, in on the number in front of the x. So let's see if we can make a connection. Let's take that all the way up here. And so 6 is the coefficient in front of x. And in this little formula, it says 4p is going to equal 6. So we will put that over here. 4p equals 6. So p is going to equal 6 over 4, which is 3 over 2. Or if you want to make it a decimal, it's going to be 1.5. So p, remember, is the distance from the vertex. And so let's go ahead and sketch this out right down here. So that's going to, let's just make a little xy axis. So the vertex is 2, negative 1. So right 2 and down 1, there is the vertex. And let's go ahead and draw the parabola. It's going to be opening up to the right. And P is the distance from the vertex, to the focus. So that's going to be a distance of 1.5. And remember, the focus is always inside of the parabola. So it's going to be a distance of 1.5 to the right. So therefore, the focus is going to be 3.5, comma, negative 1. So 3.5, comma, negative 1. And then the directrix is simply going to be 1.5 to the left of the vertex. So if this vertex is at 2, then you go backwards 1.5. That's going to be a equation of x equals 1/2. And once again, let's review. That's going to be just a vertical line that is some distance p from the vertex, and this is some distance p from the vertex as well. That's your focus, that's your directrix, and we've also found the vertex as well. Okay, in this last example, it says write the equation, and I'm going to change that. It should say write an equation for the parabola that has the vertex 1, negative 3, and another point on that parabola of 5.5, comma 0. Notice they don't tell you whether the parabola opens right and left or up and down. So this is where you have a choice. And so let's just kind of draw this out here. We have a parabola that has a vertex of 1, negative 3. So that's right 1 and down 3. So there's your vertex. And then there's another point at 5.50. So 2, 3, 4, 5.50. So we have the option. We could draw it going right and left, or we could draw it going up and down. And I'm going to just choose to draw this parabola opening up to the right. And so I'm going to use this equation right here. So it's y minus k, and k is the y coordinate of the center. So that's going to be y plus 3. squared equals 4p. P is the letter we don't know here. And then it's x minus h. H is the x-coordinate of the vertex. I said center, so I meant to say vertex. And now we're going to plug in the other point they give us, 5.5 comma 0 for x and y. So 0 goes here for the y. So that's going to just give us 9. And then we have 4p. And then 5.5 minus 1 is 4.5. And 4.5 as a fraction is 9 over 2. And now I'm going to multiply both sides by the reciprocal of 9 over 2, which is 2 over 9. And when I do that, the 9s are going to cancel. And I am left with 2 equals 4p. Now notice I'm not solving this for p because all I really need in this equation is not p but 4p. And we see that 4p is equal to 2. So now I can go back and I can change this to y plus 3 squared equals 2x minus 1. And that is an equation for the parabola that goes through that point as a vertex and has another point, 5.50. You would have gotten a different answer if you drew your parabola going up and down.